Hi, in this video we're going to learn how to write an equation of a linear relation from a real-world context. So the learning goals for this video are to be able to represent linear relations as equations when they're given as written descriptions, graphs, or tables of values, and then also to use these equations to solve a problem in a real-world context. So let's imagine that you've got a cell phone plan. It charged an activation fee of $100, so that means before you even use the phone, you were charged $100 to start. And it charges a rate of $40 a month. So we're going to graph that relationship, and we're also going to complete the table here. So let's think about this. Before you even start using the phone, you have to pay an activation fee of $100. So at 0 months, you could put a point here at 100 because that's what you paid right at the beginning. Now, at 1 month, you used 1 month's worth of this plan, so that's $40. So that's 40 plus the $100 that you paid at the beginning for a grand total of $140, which is right here. Now, after 2 months, you could say you did 40 per month for 2 months, so that's 40 times 2, so that's $80 plus the $100, so that's $180 in total. Now after 3 months, that's $40 a month for 3 months, so that's $120 plus the $100 for a grand total of $220. And then for 4 months, so that's another $40. You can think about it like that. Or 40 times 4, that's $160 plus the $100 you paid at the beginning, so that's $260. So anyway, we've got a linear relation right here, and we'll just connect the dots. All right. So let's fill in the table here. We can see it on the graph that at 0 months, you have to pay $100. After 2 months, it was at $180. After 4 months, that is $260. Now here at 9 months and 15 months, though, I mean it's not on the graph, but we can still figure it out because we know that you have to pay $40 a month. So for 9 months, that's 40 times 9, so that's $360 plus the $100 for a grand total of $460. Okay, so again, that was 40 times 9 plus the $100. So that's 360 plus 100, so that's 460. Now also, we can do the same thing for 15 months. It's $40 a month for 15 months, so that's 40 times 15 plus 100. So 40 times 15, that's 600 plus 100, so that's $700. So we're going to generalize this to create an equation to show how we calculate the total cost after n number of months. So remember, the total cost was $40, okay, times however many months, whether it was 2, 4, 9, or 15. So it's 40 times n, which is the number of months, but don't forget you had to pay $100 at the very beginning. So this equation here models how to calculate the total cost of a cell phone plan, of this particular Rogers cell phone plan. Okay, it's 40 times however many months plus 100. Or you can write this as $100 plus 40 times however many months. You can just switch it around. Okay, so there's 2 forms of this equation that we can use to represent how we calculate the cost. Now let's use this equation to determine the total cost of using the Rogers cell phone plan for 2 years. Now remember, n is the number of months, so we need to know how many months 2 years is. Well, 12 months a year times 2, so that's really 24 months. So let's use our equation here. C is equal to 40 times n plus 100. Now remember, n stands for the number of months, so I can replace n with 24 plus 100. So 40 times 24, that's 960 plus 100. So the total cost would be $1,060. All right, let's try this again, but with a rival cell phone company. Here's a graph of Bell's cell phone plan that relates cost in the number of months. So let's complete the table here. So I can see for the first couple, at 0 months, it costs $120. So that must be the activation fee for this Bell plan. At 2 months here, it is at $180. Okay, now here's the problem. I don't know how many dollars it is for 8 months or for 19 months because it's not shown on the graph. So let's figure out how much you pay a month. So what do you pay per month? Well, we can figure that out by calculating the rate of change. So let's go ahead and do that. Remember, you have to pick 2 points to calculate the rate of change. I'll pick this first point here. That's 0, 120. And I have to pick another point here. Let's just pick this point, 2, 180. Okay, let's calculate rise over run. Remember, so we're going to subtract the y numbers. And then for the run, we're going to subtract the x numbers. So I'll do 180 minus 120 divided by 2 minus 0. So that's 60 divided by 2. That's 60 for the rise, right? These numbers are in dollars. And for the run, they're in months. So if I do $60 divided by 2 months, I get $30 per month. So this plan has a rate of $30 a month and an activation fee of $120. So for 8 months here, we can figure that out for what the cost is. So the cost is, let's see, it's $30 a month for 8 months, and then we got to add 120. So that's 30 times 8, that's 240 plus 120. So the cost is really $360. Now we can use that same method to find 19 months, right? So that's 30 times 19 plus 120. Let's back it up, 120. So 30 times 19, that's 300 plus 270, so that's 570 plus 120. So we get $690. Can you create an equation to show how you can calculate the total cost, C, after n months on Bell's cell phone plan? Well, I sure can. It was $30 a month, right, times however many months you're talking about, plus the $120 for your initial activation fee. Okay? Now you can write it the other way around, 2 plus 30n. Both are valid. All right, let's use the equation to determine the cost of using the Bell plan for 3 years. So again, 3 years is really 36 months. Oops. So let's use the first equation, 30 times n plus 120. Now, I know n, the number of months, right now we're talking about, is 36 plus 120. So 30 times 36, that's 900 plus 180, so that's 1080 plus 120. So that's equal to $1,200. So what we're going to do is we're going to figure out, well, is there a general way to make an equation of a linear relation? So let's look at the Rogers and Bell equations together. So remember, the Rogers plan was 40 times n plus 100. The Bell plan was 30 times n plus 120. Now, if we take a look at what these numbers meant, right? This 40 here and this 30, well, they were both the rates. So these two numbers here were the rates that they were paying, right? And the other two numbers, the 100 and the 120, well, those two numbers were what you had to pay at the beginning. So these numbers here, we considered the initial value, okay, or the initial charge in this case. So if we know the rate of change and we know the initial value, then we just build equations like this. Okay? So in general, an equation of a linear relation takes the form of, this is what we call y equals mx plus b. Now, the y, the reason why we write y here was, you see how the letters here at the beginning were for cost. Now, cost is over here on the y-axis. Now, it's not always going to be cost. It could be distance, it could be profit, it could be something else. So we won't use c all the time. We'll just use whatever it is on the y-axis. Okay? Now the X, again, in the examples that we had, they were always months, but they're not, I mean, here it could be anything else. So instead of writing months or N, we'll just use whatever it is for X. Okay. The M is for the rate of change. Okay. So the rate of change is always multiplying with whatever the variable is for X. And this letter here, B, is the initial value. Okay. Now, remember the initial value we found over here, okay, on the graph. So that point here, where the graph hits the y-axis here, we also call that the Y-intercept. Okay. So if we see it on a graph, we can also call it the Y-intercept, but in general, it's also called the initial value. Okay, so this in general is how we build equations. Okay, and we'll refer to y equals mx plus b quite often. We're going to given the graph, we're going to create an equation for the relationship between the profit, P, and the number of unsold items, N. So, remember, we're going to need two things. The initial value, which we can look at on the graph. So the initial value is right here where the graph begins. That's at 110. But then we need the rate of change. Now, the rate of change isn't given to us in this question. That means we're going to have to go get it. Now, if we have a graph given to us, we can always go and get it. We just need to pick 2 points and then calculate rise over run. So this point here at the beginning is 0 and 110. And let's look at this other point. Let's pick that one there. That's 25, 70. All right, so let's calculate rise over run. So let's do 70, take away 110, over 25, take away 0. That's negative 40 over 25. And if you divide those, you should get negative 1.60, I guess, dollars per item. All right, so now that we know the rate of change and we know the initial value, we can go ahead and make our equation. Now remember, every equation should go in the form y equals mx plus b. So I'm going to write that there, and I'm going to use that as a template for me to make my equation. So the y, remember that stands for whatever the numbers y on the y-axis mean. And in this case, it means profit. So I'm going to use a letter P for profit, is equal to M. The M stands for the rate of change, which we just calculated as 1.60. X stands for the whatever it is these numbers here mean, and that means a number of unsold items, N, plus B, that stands for the initial value, which in this case is 110. So here, this models how profit relates to the number of unsold items at a store. Now, if the profit at a store is negative 290, so that means they lost money, how many items were left unsold? So we can use our equation here to solve for N, the number of items left unsold. So the profit is negative $290, and that's equal to negative 1.60 N plus 110. So let's solve for N. Let's subtract both sides by 110. So that'll get me negative 400 is equal to negative 1.60 N. Now to isolate N, we're going to divide both sides by 1.60. All right, so those will divide away. So N is equal to 400, and it's negative, divided by 1.60, and it's negative, and that'll equal 250. So how many items were left unsold? 250 items unsold. Okay, so we were able to solve a problem by first modeling the relationship between these two variables. Okay, so that's the big idea. Can you make an equation using the initial value and the rate of change, and then substitute to solve a problem? In this case, we had to solve an equation. Okay, so hopefully this made making equations for linear relations pretty clear, and also how to use them to solve a simple problem afterwards. Okay, so thanks again for watching. Take care.